gonna do.
Yes, some guy.
No, is it?
You know, it's always one of his buddies.
Oh, yeah.
Never know stories about him.
Good guy. Good kid.
We're gonna do that.
Whatever.
Me
Alright.
neither.
Let's do a Google search. Adam Guy's Drive.
You put in doctor.
Doctor.
No,
You did get that.
There's an author, a very well-known author.
Dr. Ivan,
Wait a minute, it's not
Like-
Adam Meisner.
19.
yeah.
Oh, wait, my God,
Wait,
you're on the
19?
top.
Oh, sorry. Ron is the other one. So, 19 says the blood transports, explain how blood transports oxygen and carbon dioxide. Discuss 3 factors that mitigate the release of oxygen to the body tissues. Okay, so this is basically one big racetrack. Here's our racetrack. Okay.
Oh,
Now, here is a,
I cannot figure out my picture.
there's a peanut.
We don't do, when we just did 7.
Oh, wait, don't do that.
Oh.
No peanut.
We're gonna make a peanut here. A peanut.
Okay, that'd be a little confusing.
Okay, now, that's actually a red blood cell. Remember, it's a biconcave disc. That's why we got the peanut shape going.
I'm sorry.
It's delicate flower, you are.
Sorry,
Okay,
I
so-
can't help it. I'm really trying not to.
I did it here.
Now,
I haven't been drinking.
yeah, it's just,
That's a long story.
this
Sorry.
is the alveoli. Remember that?
Yeah.
The alveoli. That's that little tiny air sac that's in the lungs. Okay, so this is supposed to be fresh air that's been brought down in. So here is our red blood cell at this time. Now remember, it's filled with hemoglobin. And the hemoglobin has the ability to carry oxygen or carbon dioxide. But right now it's just hemoglobin. Now what we're trying to do is we're going to pick up oxygen from the fresh air. It's going to combine here. And when it joins the red blood cell, the actual blood cell will become red, and it'll be hemoglobin bound to oxygen. We have a name for this kind of hemoglobin. We call it oxyhemoglobin. Now, when this red blood cell
Right. We love you anyway.
is making its way to the tissue cells,
I don't mind it until somebody made me eat.
the oxygen is going to be released to the tissue cells. And then it'll just be hemoglobin again. That's the idea. Now, to drop off the oxygen, there are 3 reasons, or 3 things that are going to influence its release. So right here, to get the oxygen to unload, there are 3 factors that affect oxygen release.
Hey, I had that.
Okay. What are the 3 factors?
The blood concentration of carbon dioxide,
Okay, CO2 level,
the blood pH,
okay, pH,
and the blood temperature.
okay, temperature. All right, now, the idea is the tissue that is the busiest gets the oxygen. That makes sense. So if I'm using my leg muscles, well, heck, that's where the oxygen needs to be. If I'm digesting my hamburger, well, I'm gonna need oxygen and blood in that area.
Okay, the tissue that is working the hardest.
Yeah, the working the hardest gets the oxygen. So, tell me, a busy tissue, does it generate CO2 when it's doing its Krebs cycle?
Yeah.
Yes, so if there's lots of CO2 in that area, that would be a good place to unload oxygen. Okay, because that means the tissue is busy. Also, when a tissue is metabolizing, working hard, it's going to be using up fuel sources, right? And every time we burn fuel, we will generate some form of acid. So the pH number will be acidic around the tissue that's busy. All right, so if the pH number drops, shifts to the left, that will make the oxygen release in that spot. The other item is if you're metabolizing, the temperature increases. So the more fuel that you use, the hotter it will be in that spot. So all of those factors will influence the release. Oxygen can get off anywhere along the way.
Okay, now what did you say about temperature?
The hotter it is, the more likely the oxygen will unload in that area.
If you're working like your arm,
Yeah.
it's getting harder. Good hard.
Hot. Okay. So those are the three factors. Now the hemoglobin's all on its own. Now don't forget this. We have a cycle going on in these cells. What's that cycle called? Starts with a K? Krebs cycle. So that's to make energy. It also makes CO2. So that's the source of the carbon dioxide. Now, the key is when it enters, I'm going to draw 3 arrows. That's because there are 3 carbon dioxide pathways. I could take the carbon dioxide and just dump it into the plasma. That just means take the gas, dissolve it into the plasma. We could just do that, then it would go away. Or we could have the carbon dioxide enter and bind to hemoglobin, and then what will it be, Mary Jo?
I don't know how to say it.
I love how you say it, could you please, with the accent.
Carbamine hemoglobin. Okay, so that's gonna make carbamine hemoglobin. Now, if you can just flat out spell that, user would be in there. Okay, now what? Hemoglobin. Give old Mary Poppins a run for her money, won't we?
It reminds me actually of the Muppets when you're doing Google. That's what kind of reminds me. Yeah.
So,
That's the Muppets, right?
Yeah.
So young.
She
Huh?
knows the muffin.
She
It's
knows.
sweet and
She
innocent.
knows all about that stuff.
She's not sweet or
What are they talking about?
innocent. She used to be. Till she went
Yeah, just after this
outside.
class. Your ears burned off.
Ah, it's working with the bumper sticker.
Yeah,
she got her
yeah, she
wallflower.
got- So, now. Three,
Can we go with digestive?
yeah. Now,
Melissa. It's never gonna go away.
now, there's a third path. We can actually make that. Make bicarbonate ions. Now, in the book, they talk about these three pathways. They also assign a percentage number. So the one at the top is done the least, 7%. Carbaminohemoglobin coming in at 23%. Then 70% here. Now, I just got a new textbook and they changed the numbers on me.
Aw.
Of course they can.
But we understand the pathways. Now, here is the blood cell. Now, I could just have CO2 here, right?
First.
Just dissolved into plasma. How much does that?
7%.
7%. Or it could have combined with the hemoglobin like this. See the two together? That's carbaminohemoglobin. That's 23%. Or it can do some chemical reactions and actually generate this HCO3 like that. That's 70%. Now, there is a little feature here. When this bicarb shifts out, what shifts in? Chloride. Now, this little feature is called the chloride shift. Now, when this blood cell gets to here, the chloride will be, it shifts in on the venous blood, and now it shifts out on the arterial side. So if we would measure chloride in the pulmonary arteries and veins, they're different. So on the opposite sides of the heart, the chloride value changes. So chloride shift is very in this topic. Here's our three factors that affect the release of oxygen. And then here are the three pathways that carbon dioxide can take through. That's our topic here for respiratory.
Simple, simple, makes you simple.
Moving right along.